The Doppler effect is an increase or decrease in frequency of waves received by an observer as the source moves towards and or away from the observer. Now you have a shift in waves. It could be a shift in sound waves, or it can be a shift in other electromagnetic waves such as light waves. Let's look at sound waves for the Doppler effect. Here we have a stationary car. A person in the car is pounding on their horn. They're repetitively pounding on their horn, and we can see this sound wave front spreading in both the behind direction from the car and the forward direction of the car, as well as in all directions. Notice that the spacing between the wave fronts is exactly the same before the car and after the car, and this is because we have a stationary source. The car is not moving. So a person that's in the path of this sound wave is going to hear a certain frequency, which I will label F sub S. S for stationary because the car is just sitting there. So they will hear some kind of frequency which we've labeled F sub S. Now, if the car decides to move in the direction of the observer is going to hear a different frequency. That frequency is going to be a higher frequency, which I will label F sub H, H being higher. As the source moves through the observer, still blaring its horn, notice that the wave fronts have moved closer together. Therefore, the person will hear a higher frequency labeled F sub H. Now, after the car passes, the same observer is going to now hear a lower pitch, lower than the stationary pitch, and we're going to label this F sub L, L being lower. Notice that the distances between the wavefronts has increased. It's larger than in the stationary wavefront case. Because it's larger than the stationary wavefront case, we've labeled it F sub lower because the person is going to measure a lower frequency. The shift from stationary to a high frequency, then to a low frequency, is what we mean by the Doppler effect, and in this case, for sound. It is an increase or decrease in frequency of waves received by an observer as the source, which is the car in this case, moves towards and or away from the observer. In this case, it's only away from the observer. Let's take a look at this animation. Here we have a car. The sound is being emitted. As the car moves forward, it's pushing those wave fronts together, and you're going to hear a higher frequency in front of the car. After the car passes, you're going to hear a lower frequency. This is what we mean by the Doppler effect, and in this case, for sound.